Mari's computer has 3 memory cards with 64 gigabytes of space each, and 2 memory cards with 16 gigabytes of space each. The files on her computer use 78 gigabytes of space. How much memory does her computer have left? Okay, first of all, I'm a student and I'm reading, and all of a sudden I see this word gigabytes, and I'd say, how do I even read that? Maybe that's a word that I don't even know how to read. Okay? So I can get stuck on just that word and start thinking, what does that word say? And I could spend 20 minutes trying to figure out what that word says. Does anybody feel like the word gigabytes is a really important word to be able to read?
No.
Can I just call those G's? Whatever that is, that word that I don't know, can I just think, okay, those G's. Keeps talking about G's. Can I safely feel like that might work for me? Because it doesn't matter what gigabytes are. My lesson here, and I'm reading the problem, I don't want to get stuck on the word gigabytes. I know it has something to do with memory cards. I may not even know what a memory card is. I don't care in this math lesson what a memory card is. I know that memory cards apparently have gigabytes on it because it tells me that in the story question. And that's really the only information I need to know. Now, in order to picture this, I might do something like, okay, there's some memory cards with 64 gigabytes of space each. So I might just draw myself a little picture. 64, here's my cards. They actually look like three little squares, right? 3, how much do each of those have?
64.
And I looked at my problem in here and, oh, look it does kind of a bar model, doesn't it? Okay. But I can draw this visual for myself to think, okay, there's 3 cards and they have 64. And then it says there's 2 memory cards with 16 gigabytes of space. So I'm going to go right here and I'm going to draw 2 memory cards. How much do these each have?
16.
16. So I'm just going to go ahead and put those there. I'm doing okay on my problem so far, even though I don't know about memory cards and gigabytes. The question says the file on the computer uses 78 gigabytes of space. How much does she have left? Well, this is how much she starts with. So I'm going to need to start figuring out how much she has altogether. This one is a total. They have it on the bar model here, a total. What are some ways that I could use to solve that? To find that total? What's one thing I can do? Monet. 64 times 3. That's the way they did it here. Is there another way to figure that out? Yeah, I could just add them, right? I could do 64, 64, 64 this way. Okay. So there's two options of how to find the total of 64 times 3. Did anybody do it yet?
Yeah, 192.
I know that that's the right answer because I looked down here already.
32.
So then I go down to the next one. Again, I'm trying to find the total of these two, and they are 32. We can do 2 times 16, or we can do 16 plus 16. And we already know that it's 32 because we've looked ahead. And then to find the total, remember we want to know if she has 3 cards that are 64 and 2 cards that are 16, we want to know how much that is altogether. Would we multiply those 2 numbers? No, what do we do with them? Add them. And you can see again we've made a bar model of both of those together with the 192 and the 32 over there. And then we're trying to figure out what the total of all that is. When we add those together, we get 224. All right, the files use 78 gigabytes of space. That was going back to the question. So a lot of you will get to this point and go, okay, the total is 224. Is the answer 224?
No.
Because the question wasn't what is the total. The question is how much does she have left after using 78? So I want everybody to look up here. If she has a total of 224, but she's used 78, how are we going to find out how much she has left? Okay, while you guys were talking, I listened, and I set it up, and then I'm going to subtract. So I'm going to make sure I regroup right. You guys help me make sure I regroup right, because Miss Harris does make mistakes. 14 minus 8 is 6. 11 minus 7 is 4. The order of operations is a special set of rules rules. Here's some rules. It gives the order in which calculations are done in an expression. First you multiply and then divide from left to right, and then you add and subtract. Let's look at what that means. If this is my problem, this was the problem we just did. Are you guys recognizing the numbers? So far, so good? Okay. So we had 3 times 64. Do you see that here so far? And then we had 2 times 16. That's right here. Did we add those two numbers together to get a total? And then we took that number and we subtracted the 78. So far, do you see that? Let me show you what happens if you don't solve it accurately. First, we do multiplication and division all the way across before we do any adding or subtracting. So when I see this number, 3 times 64, what did I get was my answer? 192. Okay, 192. If I add 2, that's my next step. Do you see how it says add 2? Let's add 2. What's 2 plus this? So now I'm at 194. Now I'm going to, then it says multiply times 16. 194 times 16. So I have 3,104. So 3,000, I should have just grabbed my calculator. 104 minus 78. Is that going to give me 146? Is this answer, do I even have to do the subtraction to know that that's going to be in the 3,000s or 2,000s?
No.
My answer is going to be huge. Is that the same answer I got here? What did we do wrong? That's what order operation says, is do all the multiplication parts first and then add. So let's do this again. The multiplication of 3 times 64 is, here's another multiplication fact. So I'm going to do those. 2 times 16 was 32. Now I can do the adding and subtracting. So, oh, it's right here, they did it. 2 times 16. They just did it in all the steps. You don't necessarily have to do this. So now I have 192 plus 32 minus 78. And then I got 224 minus 78. And then I got my answer, which was 146. 5 times 17 plus 5 times 20 minus 32 equals some number that we don't know. What is the first fact that I'm going to work with? What numbers am I going to work with, and what am I going to do with them? Raise your hand when you know. All right, what did you guys decide we're going to do first? Tell me.
Multiply.
What numbers are we going to multiply?
5 times 7.
Did anybody figure it out yet? Ooh, what did you get, Kaylee?
85.
Okay, then I'm going to finish writing the rest of this. Is all that's happened there, is they finished writing the rest of the problem. So you do the first multiplication fact, and then they continue writing the top. Okay, so I've already done these. I'm going to put a little line through them so that I remember that I've done those. And I found my answer is 85. What's the next part I'm going to do?
5 times 20.
5 times 20, because we're going to do multiplication first. What is 5 times 20?
100.
100 minus 32, because we still haven't done 32. So I've crossed those out, and I see that I still have the minus 32 left. Okay. Now, again, should I do the minus 32 next?
No.
I will end up with the same answer, but you should always go left to right. You should always start, like when you're reading, you should always start on this side to this side. So we did multiplication and division first, then we're going to do adding and subtracting second. So this tells me 85 plus 100, what is that?
185.
Minus 32. And now I can do 185 minus 32 is 153. Alright, what was the first thing we're going to do?
Multiply 3 times 26.
How many of you multiplied 3 times 22 first? What did you get, class, when you multiplied 3 times 22?
66.
66. Who can tell me with a quiet hand what the second thing they did was? And Marley's saying 7 times 41 is next. How many of you agree 7 times 41 is next? And what did you guys get?
287.
287? All right, so then what am I going to do next? Raise a quiet hand if you can tell. Aiden, what'd you do?
I did 287 plus 66.
This plus this. How many of you did that next? What does that add to, class? Minus 24 still. The last thing that we do, class, is what? What numbers do we subtract?
353 with 24.
And what did we get?
329.